the midterm's graded. You probably saw the grades were posted before the weekend. And we'll be returning them and discussing them in the lab sections tomorrow. In the meantime, here PS7 is coming due at the end of this week. And then PS8 will come out, and on we go. Any questions or problems? Yes?
I was wondering if you had suggestions about writing unit tests for things that use like a file picker for loading and saving.
Okay, so you're writing a unit test for like opening a spreadsheet.
Yeah.
Okay. What I would do is you got to take the file picker out of the unit test. So ideally there would be a you're probably going to need an event in your view that says this file has been chosen. And then when the controller receives that event, it will do whatever it's supposed to do with the file. So to test, you just have to, when you get that, you would fire that event with some predetermined file name without invoking the file picker. Any other questions? Yes?
Generically, how many pair programming assignments are we going to be doing?
Let's see. There'll be, so we're on PS7, then there'll be probably 8, 9, 10, 11, possibly 12, but probably not.
Okay, so 5 or 6.
Yeah. Yes?
Section 12 will be about REST client such and not spreadsheets.
Yeah, so we're through with spreadsheets after PS7. PS8 will be a REST client. PS9 will be a REST server. Yes, you're working partners from here on out. Okay? If your partner doesn't work out, let me know as soon as possible. It's kind of late to change anything right now, but I can. I've actually successfully taken 2 groups and just switched them up and made everybody happy. So that's possible. If your name is up there, these are the 9 students that aren't in groups at the moment. Now, is anyone here whose name is up there that's actually in a group? Okay, what's your name?
Adam Davies.
And you're partner with who? Okay, so the 2 of you need to get your group set up and get your name off that list. Okay, so I guess it's down to 7. Anyone else? Is anyone here that's name is up there that isn't in a group? Okay, so everyone else that's here is in a pair. So I just need to get 7 people. Yeah?
We're allowed to change spreadsheet panel, right?
Yeah, you can. She asked if you can change spreadsheet panel. Yes, you can modify it all you want. You don't even have to use it. You prefer. Yes?
Is it okay not to?
Yeah, it's okay not to, sure. Other questions? Okay. Now, despite the fact there's a lack of questions, I know that lots of people have questions about how they're supposed to be structuring this GUI. And the reason I know it is because people have asked me, and also because when I explained how I wanted you to structure the GUI, the class pretty much sat in silence and just wished for the hour to be over, for the class to be over. And at the time, I even mentioned that, well, this will come back to haunt you when PS8 comes out, or PS7 comes out. So, what I want to do is talk. I've got a couple things in mind today. They all have to do with GUI clients, and I want to use the opportunity to remind you how I want these things structured. So let me get to Visual Studio. Actually, this will do to start with. So this is a UML diagram of the the final version of the file analyzer project that I used to explain the MVC, Model View Controller. And let me go back to it, and we'll look at this and we'll also look at the code a bit and see what's going on. But this stuff over here has to do with launching the program and creating new windows. So this isn't really crucial to my discussion. It's the stuff over here. So for the file analyzer, I split off the model, so I have a model. So in your case, that would be spreadsheet, your spreadsheet files. Then we have a controller, and this is the view analysis window. So we have model, view, controller. Now my goal is for the controller the controller has to know something about the things it's controlling. It's coordinating the model and the view, so it needs to know about them. But I want to make it so the model does not have to know about the controller. And I want to make it so that the view does not have to know about the controller. And you can see here, the analysis window does not have any sort of reference to the controller, and neither does the model, because these are one way. Now, it's no big trick to make the model so it doesn't have to know about the controller. Why? Think of your spreadsheet class. Yeah?
The controller is just calling methods in the model, and the model doesn't direct the controller.
Yeah, you spent 5 assignments creating the model, and you didn't worry, there was no mention of the view. So it's been designed from the outset to be usable without reference to any particular view or model or controller or whatever. It just has methods that return values. The intent is you should be able to use that spreadsheet class if you got implemented correctly without having to modify it in order to support what you're doing. So anyway, model, that's the easy part. It's harder to separate the view from the controller, to write the view so it doesn't know anything about the controller. And the reason is, anything that happens in the GUI originates in the view in the form of events. So think about your spreadsheet. You know, the user is going to open a window, and then they're going to select a cell. That causes an event. They're going to type something, a contents in and press enter, another event. They're going to click new or click open. All those are events. So anything the user wants to do originates as an event, a low-level event inside of your view class, inside your spreadsheet GUI class. And if you're not careful, what you'll end up doing is putting all the functionality of the controller into those low-level event handlers. And that's not what I want. I want you to put the high-level control information into the controller. So how is it that we can sever at least one direction of the connection between the controller and the view? Why is it that even though everything originates in the view doesn't have to have a reference to the controller? What technology makes that possible? Yeah? Interfaces. Interfaces. And that's true, but there's a more important reason there's a separation. Yeah?
The event delegates?
Events. Events are the key. So what the view provides, first of all, it has low-level events because anytime you put boxes or buttons or menus into your view, you're going to have to deal with the events that occur when they're clicked. So I'll call those the low-level events. Then your view also has to provide high-level events that are subscribed to by the controller. Now, what would be some high-level events that might occur? Yeah?
Modify cell contents.
Okay, think of an event called modify cell contents. That might be a high-level event, so modify cell contents event. And that might occur when the user has selected a cell and typed something into a box to set the new contents and hit enter. Okay, so there'll be a low-level event that the enter key has been pressed. But what you've got to do is say, okay, when this enter key was hit, and so I should fire a cell contents change event that takes as parameters the name of the cell that was changed and what it was changed to. So we've turned a low-level thing into a high-level thing that takes a few values, the current cell, the contents that have been entered, and fires an event that contains those two pieces of information. The controller then will be listening for those events. And so when the event is fired, suddenly the controller wakes up, says, a cell contents change event has been fired. And what will it do? What will it do with that event? What would that event handler look like? Yeah?
Won't it call an interface method, like one of the methods from the interface?
From what interface?
The spreadsheet interface in our case?
Okay, so you have methods in the spreadsheet class, right? You have set cell contents or set contents of cell or whatever. And so you'll take the information that came in the event, you'll call set contents of cell, you'll get back an enumeration or a set, can't remember which, say a set of all the cells that need to be redisplayed. Okay? Then what would this event handler do? It's still trying to deal with setting the cell contents. Yeah?
It's going to iterate through that set and then just update the view.
Okay. So then it's going to have to look, it's going to have a whole bunch of, a list of cells that have changed. And so it'll need to iterate through the set, go over to the spreadsheet, say what's the value of this cell, get it, and call a public method on the view and say change this cell to this. Get the next one, change this cell to this. So the controller is going back and forth between the spreadsheet and the view, getting information, updating the view, getting information, updating the view. And that's all triggered by this high-level event. So what the view is doing is taking the low-level event and mapping them to high-level events that the controller is interested in. The controller wants to know about events related to spreadsheets, not events related to buttons. So contents has changed. Another event might be open spreadsheet event, and the parameter would be the name of the file that contains the spreadsheet. Stuff like that. So the events you're creating should be related to the spreadsheet. Okay? So because they're events, the controller doesn't have to have an explicit reference to analysis. Instead, it just has to, I shouldn't say that. The analysis window doesn't have to have a reference to the controller. Okay? The controller just registers for events. Okay, what's the role of that interface up there? So analysis window implements that iAnalysis view interface. What's the purpose of having an interface? So the controller refers to the analysis window through that interface. What advantage does that give us over referring directly to the analysis window? Yeah?
You can change how the interface is implemented for the tests and
Okay.
for the view.
So the idea is the controller will work as long as you provide it with a class that implements that interface. Well, one class that implements the interface is your analysis window. But for testing purposes, we're going to take this out and substitute in a different implementation that lends itself to testing. We'll talk about that next. So that's why we go to the analysis window through the interface. So we can replace this part with something else to allow testing in the controller. So that's how we get the separation. So what you have to design, one of the first things you need to think about is what high-level events do I need to expose to the controller? And I've suggested a couple. Sort of a, cell contents changed event and a open new spreadsheet event. They're not going to be a whole lot. You might have an event that, think about the user clicking around from cell to cell. Every time they click, it's going to have to display the contents. So there might be an event that says, selection changed, in which case you have to update what's displayed for the contents. So it's just, it's up to you, but think at a high level. So you're still sitting here quietly the second time through. So, but things due in 2 days. So if you got any questions at all, I'm sure your classmates would appreciate you asking. Yes?
So it's the view that implements the controller interface? Does that help?
The view implements the view interface. Yeah?
Can you show us how you had that interface in the code?
Okay, so we'll go to Visual Studio here. Here I am in the File Analyzer. And what I want to look at is I'll go to File Analyzer 5 here. And we will look at the iAnalysis View interface, which I sort of did in a hurry and didn't end up with any comments. So I apologize for that, and we'll make this bigger. Oops.
Are the events in this those high-level events that you're talking about?
Yes, the events in this interface are the high-level events. So this interface is what the controller sees. This is all the controller knows about the view. So the controller doesn't know about the names of the boxes and the menus and anything like that. It just knows that it's possible in the view for someone to choose a file to open. And so when that file chosen event is fired, along comes the name of the file. Yeah?
So the analysis window is the thing that we would implement a stub version of if we were
Yes.
testing file anyways.
Right.
And it would still implement this.
Right. So analysis window implements this. There's also a stub version to implement this for testing purposes, and we'll talk about that
And
later.
we won't have to change this interface now.
Right.
It's just
The idea is
the
you don't
same.
have to change the interface. Another event that can be fired is the user has entered a string and wants to account how many times it appears in the file. And so in that case, a count event is fired with the string to search for. A close event. The user has hit the close menu. A new event. The user wants to open a new window. So my view, I have chosen to expose 4 high-level events to the controller. So from the controller's point of view, that's all that can happen inside the view. One of those 4 events can get fired. Now, when they get fired, the controller has to do something. And yeah.
So in this particular example, even something as basic as new spreadsheet, like equals new spreadsheet, that's happening at the controller.
Yeah. If it's something to do with spreadsheet, if it's something that involves using the spreadsheet class, it has to go through the controller. Because the view absolutely does not know anything about the spreadsheet object. Yeah?
If we have like a pop-up window or some dialogue, is it okay if that's all defined in the controller?
Yeah, I mean, it's sort of an art to decide on the what belongs in control, what belongs in the view. But I'll give you an example. I could have had an event here that says user wants to display the file chooser. But instead, I kept all the code that brings up the file chooser inside the view. And only after a file has been chosen do I fire the event. So I chose to put that bit of that bit of complexity, since that had nothing, choosing the file has nothing to do with, say, spreadsheets. If I were talking about a spreadsheet, then it would make sense to keep that over there. So yeah, you sort of have to decide. Sometimes it's debatable which side of the divide to put things on, but anything that has to deal with the spreadsheet object definitely needs to be in the controller. Yeah?
I just want to clarify. So you have fields in your interface. So that means that keeping track of, say, a current selection is not beyond the functionality of the view, right? Is that something that we can keep track of in the view and then pass through the interface?
So you're looking at these now?
Yeah.
Well, first of all, notice these only have setters. So the rest of the interface consists of properties and methods that the controller is allowed to use to modify something over on the view.
So having a getter would be too much.
Yeah, my idea, I can imagine putting a getter in, but the way I design this is all the information you need comes via the events. And so, for example, if I want to set the search string, or set the line count, or the character count, or the substring count, or the word count, or the title, I've got properties I can set via calls from the controller, and that'll affect the view. Or if I want to close or open, there are methods to that. Yeah?
The part that I'm understand about is, I understand the distinction between a low-level and high-level event. However, so are the low-level events
Low-level events are fired by the GUI. I mean, someone clicks on a button, then there's a low-level event, and you'll have an event handler you created to deal with that button press.
Okay.
That event handler will decide what high-level event, if any, to fire.
So there won't be any low-level events in the interface.
Right. Interface does not contain low-level events.
So the GUI, we have those.
Yeah.
That fire the high-level events that the controller is.
Right.
Okay.
And we want to be able to make sure those high-level that the reaction of those high-level events is testable. So that's why we're going through this. Why we're doing this separation. Yeah.
So for the arrow key, is it going to be like the view class is going to capture the event, and then you have another some kind of method or some kind of instant variable in your controller class that store whatever cell is being selected?
No, I don't think that the controller needs to store the cell that's selected. Maybe there needs to be an event that says selection is changed.
Okay.
And what should happen when the selection changes? What does the controller need to change about the view when the selection changes? What's highlighted, although I can imagine just taking care of that at the right inside the view. But yeah, it could control, you could change, you could say selection is changed and you have a method that says highlight. But what else needs to change? The contents that are displayed somewhere else. And so there have to be some callback to change the contents that are displayed. Do you have a question? Okay, so you just need to figure out what the high-level events are, but they should have something to do with spreadsheets, not to do with, shouldn't have to do with buttons. You should be able to completely rearrange your GUI and rename the buttons and everything without affecting the high-level events. Okay, so we're going through this rigmarole because we want to be able to test. So, you look at this is File Analyzer 4 Tester, and this was split off in File Analyzer 4, which didn't have a separate model. This doesn't show a separate model. It would if it were split off File Analyzer 5. But what we've done is we've got exactly the same controller here. But now there's a unit test box that's driving everything. So unit test array. And instead of the analyzer window, we've got an analysis view stub, and we've got the same interface up there. All right? And the idea is that the unit tests do have access to analysis view stub. And so what will the unit test be doing? How do you test the controller? Yeah?
Manually fire the events and make sure the right things are being done.
Right. So it'll say, I want to find out if, I want to see if the right thing happens when I fire the contents changed event. So it'll, since it has access to the stub, it'll call the, there'll be a method provided to fire the contents changed event. It'll fire. The controller, since it's listening for those events, will find out about it. It'll interact with the model. And it will make calls back into the analysis view stub to set properties and call methods. And the unit tester has to be watching and make sure that the right things happen. Simple as that. Yeah?
The analysis view stub is the analysis window.
It's a replacement for the analysis window.
Right, but it's replacing analysis window,
Right.
not something else.
Right, and it implements that I analysis view up there. So let me just show you what analysis view stub looks like. This will be File Analyzer 4. File Analyzer 4 Tester, I should say. And, oh, Tester. Unit tests. All right, so there's a unit test. So let's just see. This one here, test method 1. It creates an analysis view stub. Great. It creates a controller. So the controller needs something to control, and we're passing it these stub objects, which implements the interface that's required. The controller wants to see something that implements that iAnalysis view interface. The stub will do. And in your case, you'd be passing, as well as the stub, you'd be passing a spreadsheet object, because the controller needs both. And then the stub, the test case causes the fire close event to be fired. Okay, when that happens, the controller is going to wake up and do something. And we've got to make sure that what it does is, we've got to make sure that it called the do close method. The stub is supposed to call the do close method in that situation. So we've got to have some way of knowing that that was called. Okay? So let's look at the stub itself. Okay? Here's the stub itself. So I have a property called do close. And here's the method. So we called fire close event, and it fires off the close event. And then I have a method interface, because you have to have the interface had a method called do close. So here's do close. And for the stub, all we do is store true into called do close. Why do we do that? And in the real thing, we actually close the window. Why do we implement it that way? Yeah?
We don't know that the window was closed if we're not like worrying about it actually like visually appearing. So we need to make sure that the method that would close it is called, because that's
Right.
the
The best, we want to make sure this method gets called. This way, basically the unit test can make an assertion. It can say called do close was set to true. All right, so these methods are now going to have, they're just going to set variables that say they were called. And the rest of this, we have the events that are in the interface, and we have these properties that were in the interface. These fire events were not in the interface. They're just there so that the unit test can access them. All right? So we have to have methods to fire. In the stub, we have to have a method to fire each high-level event. We need to have the same properties and methods that are in the interface. And for each method, we've got to have some way of knowing that they were called. So that's, the stub is simple to write. It might be a lot of details, but it's pretty straightforward to write and get correct. So let's go look at another piece of the unit test. All right, test method 2 is a little more involved. So we create the stub and a controller to control it. Then a file chosen event is fired. So we fire a file chosen event, and we pass test file1.txt in. And then we assert that the title of an attempt was made to change the title of the window to test file1.txt. So the way that the controller would normally change the title is set the title property, which would result in the title of the window changing. We just make sure the property is set like it's supposed to be. We know that the answer for test file1.txt is that there's 1 line, 4 words, and 16 characters. So we make sure that these properties are set correctly by the controller. And then we fire a count event using is, and we make sure that results in the substring count property being set to 2. Yeah?
Should our window have public fields and properties so that what should we use? Should it have public variables? Should it have properties?
Properties.
Okay. So that any class can set stub.titles.
Yeah, okay, so you need a setter for each property that if you want to expose in the view, you need a setter that the controller can access. That doesn't mean it has to be public. You could make it, I forget there's an option between public and private. Protected isn't not what I mean. I think if you leave it off completely, maybe it can only be accessed inside the namespace or only inside the assembly or something. Yeah?
Then it seems sort of unnecessary to use property when an ordinary variable, either public or protected or private, whichever is needed, could do the trick. But then, or does that get too much control?
Well, then you can't make it, if you have an instance variable, you can't make it the setter private or the getter private or whatever. You can't control the visibility. I'm not sure you can even put an instance variable in the interface, which is where it needs to be. So it may well need to be a property. Okay, so I know this is sort of a lot to manage because you're writing a GUI maybe for the first time. It's almost certainly for the first time in C#. And it's not enough just to get one that works. I want one that works in the right way. And the road to success, first thing you want to think about is what events, what high-level events will the view expose, and what properties and methods will it expose for the controller to be able to modify the view in various ways. Once you got that down, that goes into your interface. Okay? At that point, if you wish, you could write unit tests against the controller. Ultimately, you'll have to implement that interface in two ways. Once in the actual view class, which would be the more complex of the two, and the other in the stub, which will just be very straightforward code that you can test against. Yeah?
Can we have instance variables in our view class?
Can you have an instance variable in your view class? Sure, you have. Every time you put a box, a text box, a button, a menu, that's creating an instance variable right there. But if you want to have others, that's okay too. Okay? The rubric we're using is visible, I think, is it not? So you can go look at the rubric and see exactly what we'll be doing when we're grading it. But part of it will be making sure you structure the architecture the right way. And so we need to refer back to something, refer back to the File Analyzer project and the examples repository. And File Analyzer 4 and File Analyzer 5 are very similar. And then File Analyzer 4 Tester or something like that is where the testing is done for File Analyzer 4. So just look at those to see what's going on. Any last questions? All right, let's take a break and then we'll look at something. right, let's get started again. Okay, now, next thing we'll be doing is a sequence of 3 assignments, maybe 4, to create a Boggle server and a Boggle client. So Boggle is a simple word game, and the idea is that we'll create a server that allows, when a client connects to the server, it's saying, I want to play a game, and when some other client from somewhere else connects to the server will pair them up and then coordinate the game between them. So we'll have to get into the details of how the game works. But that's the server's job is to pair people up and then to be the referee to make sure that the rules of the game are followed. So first step in doing this, I will provide a server. I'll have a server running on the cloud, and you will write a client that it can interact with the server correctly. So you'll have to write a GUI client that's making REST calls. So instead of, right now you've got one that's using a spreadsheet object as the model. Essentially the server becomes the model, and your controller is going to have to make REST calls up to the server. That's step 1. So that's PS8. Then PS9, you've got client now, then you're going to create the first version of the server. So you'll do that, and step 3 is you'll take that first version and you'll soup it up by having it interact with the database. And then we'll go from there. So, even though right now you're maybe overwhelmed with PS7, we need to talk about what's coming up so you can do the assignment next week. Just like when you were visiting with PS6, I was talking about this. So, we've been through this before. It's good to sort of bear down and try to understand what I'm talking about today with the REST client. Yeah?
So will we be using SQL? For database?
She asked, will you be using SQL? Yes, for PS 10.
8.
Yeah, 8, 9, 10. 10 will be the database. That's after spring break sometime. Yeah. Okay. So what I'm doing right now, so what I do is I go to Microsoft, I say, can you give me free Azure accounts for the next month for all the students in my class? And the first time I asked, they said, yeah. The next time I asked, it was yes, but there were restrictions, and hopefully I'll be successful this year. And the other thing is I asked them, will you give me a free Azure account so I can host my server? I haven't asked that question yet this year. So I'm not running my server off the cloud right now. I have 2 instances of Visual Studio running. So you can see I've got my 2 instances running. One is my server. So here I have an instance of Visual Studio that is running my server. And so I can stop the server here if I want to. In fact, I do want to. I want to clean it out, its state, and then I can fire it back up. So I've got a server running on my computer. And then I've got a client running in a different instance of Visual Studio. And when I fire up the client, it will talk to my server, also running on my computer. And that's my focus today, is how to get a REST client to work. So you got some experience with just a GUI that's more or less self-contained. Now let's make it talk to a remote server. So to bring up the client, I click Start, and this isn't a game. This is a to-do list. So I've designed this little window, and to use it, you have to enter your name and your email, and then click a register button, and then you can add tasks. So let's just try this. So I'll give my name is Joe. Email, it doesn't really matter what you enter. And now I click register, and this is going to cause my client to make a call to the REST server saying, register Joe at email XX as a user. Yeah?
Similar to the events that we are firing in the spreadsheet?
Yes, in fact what happens is when I click register, there'll be a low-level event that will fire a high-level event that the controller sees, and the controller in turn will contact the server. Okay, so I click register, and it registered me. And now I can enter a task like mow, that's not going to work. Let's say shovel snow, which is more what I've been doing lately. And I click submit task, and it records a task right there. something just went wacky because it should have provided me with two buttons here. One with a button to mark two buttons, one to delete the task and one to mark it completed. And for some reason, it didn't show up. That's upsetting. It worked before class. So, but it didn't work for a while last night until I changed something. So let's try it again. I'll use a different name. I'll register. I'll say no this time. And for whatever reason, it's not wanting to work for me. But I can make my points without it working. I'll have to fix it later. Okay? So like I said, when I click Submit Task, that fired up a high-level event that also resulted in the remote server being contacted. Now what I should have here right now is a button that I can click on to delete the task, and a button over here I can click on to mark the task completed. And clicking either of those buttons would result in a high-level event that led to a REST call. And then down here, it's kind of hard to show you what can happen down here. It's possible to display tasks for, the idea is you have multiple people using this task list, and you could see the tasks that for everyone. So if I clicked here, it would redisplay and show all the tasks that any current user has. Kind of a weird feature for a to-do list. And I could click here and it will filter out uncompleted tasks and only show completed tasks. But in fact, I guess none are completed, so if I click there, they all go away. If I click there, they come back. Now if I click here, Show Tasks for All Users, it goes completely haywire. Wow. So anyway, I got a few bugs in the system. Rats. Okay. I'll have to do some work on this before I push it. But you get the idea, is every user interface event leads to, or some user interface events, lead to REST calls being made on the server. So what we want to focus on are the REST calls, how to do the REST calls. So let's look at what's going on. So what we're in now is the to-do list client solution, which I haven't pushed yet. And here we have the various things. And let's just look at, well, let's look at the interface here, the to-do list view interface. So this shows us the controller's view of the GUI. So let's see what we have. We have a method we can call to enable the controls. So sometimes you want the controls to be disabled, sometimes you want them enabled. So we've got this call enable controls that does that. We've got clear, which just removes all the tasks that are displayed. We have add item, which is again a callback to the view that says, okay, add a new row in the table that has this description, mark it as completed or not, mark it as belongs to the user or not. We have a way we can set this property here to say that the user is registered or not. And then here are the events. So let's look at the events. There's one called register pressed. So when the user registers, that event is, when the user hits the register button, that event is fired. And what are the parameters you think that come along with it? 2 strings. What are they?
Username and email.
Yeah, username and email address. Then there's that event submit pressed. Means that a task had been submitted. The submit task button has been clicked, and along with it comes the text of the task. Filter changed. That means someone has modified those 2 checkboxes at the bottom, controlling what exactly is controlled, and so we fire off an event that contains the state of those 2 text boxes, those 2 checkboxes. This is a delete button has been pressed. That's the ID number of the task that we want to delete. And similarly, there's done press down here. So those are the high-level events that are used. And finally, cancel pressed. There's a cancel button if the REST call is taking too long, you can cancel out of it. So that's the interface that the controller sees. That's provided by the view. Any questions I can answer about that? We're about to look at how these events are actually implemented, which is really the focus of today. All right. So let's look at version 1 of the controller. Okay, so the controller, let's look what it contains as state. It is controlling the view, and I made a modification, and I should have changed that to I to do list view. So there's the view, the object it's controlling, and user token. So it knows we'll see how the server works, but there's a user token that we need to keep track of. And then it keeps track of a list of items that are supposed to be displayed. And it keeps track here of the two buttons, the state of the two buttons that control what's to be displayed. So it has sort of the state of the GUI in mind here. Then we have the constructor, which takes in the view object that's going to be controlled. And let's see what it does. Right? So it's remembering the object it's controlling. No one's logged in, if you will, so the user token is 0. Item list is empty. This is false and that is false. Then it registers, the term is hooked. It hooks all these events so that when high-level events are fired out of view, methods are called over here. So that's what the constructor does. Again, that's all familiar stuff. So let's look at what these methods, cancel, register, submit, delete, done, and filter do. Well, cancel currently does nothing. That's the difference between this and controller 2 and controller 3 is how we handle cancel. So cancel operations are ignored. Right? Here's register. So take a gander at register. And let's see what it does. So remember, what we're trying to do is register a username and an email address. So we disable the controls. So while the REST call is in progress, we don't want people to mess with the interface, except for the cancel button. The cancel button is actually activated when we deactivate the REST. We create an HTTP client. Now, before the midterm, we saw examples of doing this, not in the context of a client like this. We'll look at that method in a second. We create a client object, which you need to communicate with the remote server. We looked at expando object. So it turns out that the method that we're calling in the interface is a post method. And what we need to pass in the body of the method, in the body of the request, is a JSON object that has a name property and an email property. So we create an expando object that has a name property and an email property. This line of code here serializes it into a JSON string, so it turns it into the right format. So we create that. Then we call the post async method, so that's why we need the client. We say client.postAsync. This is the URL. It's not the first part of the URL, it's the rest of the URL. Register user is the REST call we're making. And this is what's going to go into the body of the call. So we use the post async method. And then it turns out that post async actually returns a task. And so we do .result to wait for the task to finish and get the result back. And the result is going to be a HTTP response. If it was successful, we do our thing. We extract the result object, deserialize it to get the user token that way. And we set, we do that call in the view. We set the isUser registered to true. Otherwise, we're going to print out some kind of error message down below, right here. I didn't do much with error messages, it just goes to the console. And then finally, no matter what happens, we re-enable the controls. So really, there's nothing new that we haven't talked about before, it's just packaged up a different way. So you got a question, yeah?
So the finally is like, in contrast to like catching an exception?
Yeah, you can add a finally to the end of any try. So this is a try block with no catch. And the guarantee is no matter how the try block terminates, if you return from the middle of it, if you run off the bottom and out of it, if an exception is thrown, no matter what happens, this finally block will be executed before any of that stuff actually is complete. So it guarantees this code will be executed. You don't want to have an exception that kills this method and prevents this from running. And then, because then the GUI becomes unresponsive.
Could you have a catch block too, though? Could you try catch finally?
Sure, you could have a catch with a finally if there's some exceptions you want to catch. But even if you catch it and do something in the catch block, when that block terminates, the finally block will run. Yeah?
And what's the encoding you're using when you're serializing?
What's the what?
The encoding when you're serializing the MD. Is it just like UTF-8 or something?
Yeah.
Okay.
There's the whole thing.
All right.
This is what turns the JSON object into a string. And then to create the string content object, you got to give it encoding and you got to give it a content type. So that just becomes boilerplate. You basically do that anytime you need to encode an object. Okay. So how did I know that I was supposed to use that the REST call is register user, and that the body of the REST call is supposed to contain an object with name and name and email properties, and that what got returned was actually just a JSON string containing a single ID number? Yeah?
You wrote the server, right?
I wrote the server. Right. That's a property of the server, and ideally I would have a sort of a nice API to display to you, but I actually looked for it this morning, couldn't find it. So when you do your clients, I'll have a very detailed API, similar to the GitHub API we looked at, or the Canvas API we may have looked at, that details all the requirements and expectations for using the REST calls. But this is an example of the controller making a post call to register a user. What comes back is the user token. So we record the user token, and then we set is user registered to true back in the view. Yeah?
So besides a crazy amount of trial and error, without being given an API, or without being given a description of what the API allows us to do,
yeah,
a REST server is
useless,
basically non-accessible.
Yeah. Yeah, I wonder if I have it written. Okay, a lot of times, if you contact a REST server sort of at its base URL without any extension, it'll serve you back the API. So the question is, I haven't worked with this for a year, so let's try it out and see. Let's see if I can coerce it to give me the API back. So let's go look at create client here. So go to definition. So what create client does is it creates an HTTP client, sets its base address, so that's the first part of the URL. Register user would be added to the end of that. Sets a couple headers and then returns a client. So in theory, we could find out if this worked, but it's there. Yeah, it's not quite what I expected. That's stuff generated by Microsoft. So no, I didn't do what I thought I did. Unless the nice thing about being older is there are a lot more surprises in life. No, okay. You forget a lot. Okay, I need to put that on my to-do list just to add the API documentation to this. Okay. So let's just look at a few more things. So we've got that register. To register a user, we have to make a post call to the register user endpoint up there in the server. Here's one called submit. This submits a new task, and it's going to be very similar. It turns out there is an add item endpoint, which is a post, because we call it post async, and it wants to have an object containing a user ID and a description. So we create the task object, we encode it as a JSON string. We call post async, There's the rest of our URL, and there's the body. We get the result back, which is that response. If it's a success, we deserialize it into an item token. Okay? And somewhere down here, we don't do anything with the item token, which surprises me. And then what's going on down here is we re-enable the controllers. Let's find something that's not a post. Right, here's a delete. The delete is basically calling delete async on the URL. And the actual ID of the item to be deleted shows up in the URL. It places that 0 up there. So we're saying delete item slash item number. And then we're calling delete without a body, and it does the deletion up on the server. So it's just a matter of knowing the API. All right? Any other questions I can answer before I look at the main point I was trying to make today?
Where does it pull from that bracketed 0 to get that information to pop in?
That format method. So string.format takes a string with zeros or ones or twos or threes, and then it takes a bunch of extra parameters. And so it replaces the 0 with the first extra parameter. It replaces a 1 with the next extra parameter, and so on. So if you find yourself creating a string by appending, string literal plus some value plus rest of string literal, that gets confusing. That's sort of a cleaner way to do it. There's something like that in Java too, I imagine. Other languages. Yeah?
I'm a little confused by the serialization and deserialization.
Okay, so you asked about the serialization and deserialization. So the body of the request, when there's an object that's expected in the body of the request, it has to be formatted as a string. It has to look like the object was created in JavaScript and converted to a string in JavaScript. And that string becomes the body. So what we're doing when we serialize is we're just taking an object, such as we have to go back where we're using an object, like this task object here. We create a task object with a user ID and a description, and then we just turn that object into a JSON, into a string.
But it's like a translation.
Yeah. Because in goes an object and out comes a string.
Right.
And then we have to take the string and encode it for use over HTTP.
Right.
And that just comes about because Unicode has, Unicode, every character has 2 bytes, but actually most have only 1 byte if you're using the Latin alphabet. And so you can either, various ways to transmit Unicode. And one way is UTF-8. Just leave it at that. Any other questions? Okay, so let us look at the main event here, which is this cancel button. So the idea is I want to be able to say, I want to be able to hit cancel if something is taking too long. So I have the server, I have it coded so that if the username is stall, S-T-A-L-L, it will sleep for 5 seconds before it responds, just so I get a chance to illustrate the cancel button. So I hit register, up comes the cancel button, and I can click cancel, and I guess something happened. Well, nothing is supposed to happen, so I think I'm running the wrong version. Anyway, cancel is supposed to be there so I can cancel the, I'm not sure I did succeed in canceling.
Is this the first version?
That's what I'm going to check on to make sure I have to look at demo here and see how it's setting things up. Not demo, program. Yeah, see it's using controller 3. I need to set it up to use controller 1. All right, so now if I start and I say stall and I say XXX and I say register, what my day? It's supposed to stall. Anyway. Yes?
You mentioned in controller1.cs that you had not implemented the cancel button.
That's right.
But you're still expecting...
No, I was expecting it not to work. But what's actually happening is it's ignoring stall, and my server isn't working like I expected. And
Does the email also have to be stall, or can it just be
no,
clever?
no. And I did this right before class. So now it's my server I don't like. So I'm going to go back to the server here. And restart it. Something is wrong. Now we'll go back to the client and try again. So I start it up. I say STALL. I say anything for email. I click register. 1, 2, all right. It completed. Oh, well, what can I say? So I'm not going to be able to demo it, but I can talk about how it worked. Think about it. How would a cancel method work? What would a cancel method need to do? Suppose you've clicked register and the controller has made this REST call. Yeah?
It's going to be to ask the server to not only stop, but to go back.
Okay, so we're not going to cancel the server. What we're going to do is cancel the REST call. But let me show you the problem with doing that. So we need to look, we're going to look at the controller now. So this is controller 1. And let's go look at what happens, say, when we're making a register call. So we make the register, we do whatever we do to set up the call. We call post async. So ignoring this part, this call right here returns a task. That task is executing asynchronously. Now what we do is we do that dot result on the task, and what that does is it runs a task and it blocks us until that task completes. So whatever thread is running through here will stop. If this call takes 5 seconds on another task, the GUI task will sit right here because of that dot result blocked until the other task is done and gives it the result back, and then it proceeds. So what you'll see in the GUI, if things worked right, if the server would actually stall for 5 seconds, is the GUI would freeze for 5 seconds because the GUI event thread is blocked waiting for the result of that task. Then when the task finally returns, the GUI thread would continue and terminate normally. So, see, given that, what's it look like we need to do the cancellation? Yeah?
Fire another task that removes it?
Well, we got to do something with this task right here other than just blocking and waiting for it to be done. What should we do? Yeah? Okay?
Shouldn't we have some sort of time limit to wait out?
Well, there's really not a time limit. It's just eventually the cancel button will get clicked, and we're going to. So I'm asking, I guess, what does the cancel method in the controller do? Yeah.
Try to get that task to kill.
Okay. If we could somehow kill that task, or you can't really kill a task, if you could tell the REST call itself, the HTTP call itself to cancel itself, that would be good. So let's look at controller 2 and see what we do. So here's controller 2, and it actually has a functioning cancel button. But let's create client. Okay, don't need that. That's submit task. What I'm looking for is register. Okay, here's register, and look what's different. So what I've done here is I've created a new task. After I compose a request, I create a new task which creates a client. A separate task creates a client. It calls post async, waits for the response, and then deals with the response down here. So this method runs and completes. Meanwhile, that task it created is going along. Then if we want to cancel it, the GUI thread isn't blocked. We've got everything running on a separate task. The GUI thread is not blocked, and cancel can do something. So let's see what cancel does. There's delete, there's done.
Yeah, it was above.
It's above.
Just above register.
Register. Cancel. Okay? So it's using a token source. So all cancel does is call token source.cancel. Okay? So that's not very enlightening. Let's look up here. The constructor created a token source. User token item. There's our token source. So create a cancellation token source. We've seen those before. Let's go back down to register. So register, when it calls post async, it passes to it a cancellation token. Okay? And then if that token source is ever canceled by the cancel button, this REST call will be asked to cancel itself. So it just turns out that post async is designed to take a cancellation token if you want to cancel it in the future. So what we do is we start this thing going up on a separate task, going on a separate task. It runs. If the GUI event thread sees the cancel button has been pressed, that token source is canceled, and that REST call itself is thrown out. Yeah?
So from the perspective of writing the controller, we don't have to think about the impact of the server. The server's supposed to be able to know to do all that on its own.
Right. Okay. So let's see what's involved in this task code. We create the client, we issue the request, we deal with the response. What's going on right here? So if the response is successful, we extract the user token. And then somehow we want to call view.isRegistered equals true. So why don't we just call view.isRegistered or view.isUserRegistered equals true? Why not just put it right here instead of this view.invoke? What's going on there? Yeah?
You showed us this. It's a cross something.
Yeah, sort of a cross-thread invocation exception. If you want to do anything to a GUI object, it has to be done on the GUI event thread. And this task is not running on the GUI event thread. So what we have to do is call invoke and give it a delegate. And invoke executes this delegate on the GUI event thread at some time in the future. So that's the price we pay for creating a separate task, is we have to take care that if we want to modify the GUI, we have to do it via an invoke method. Okay, that's a pain. Let's look at a better way to do it. Much simpler. Cancel is the same. And then there's register. Now, look at the header of register and tell me what you see. What's new? Yeah? Async. So that's a new thing we haven't talked about before. So we are declaring this to be an async method. And today I'm just going to tell you the highlights, and we'll delve into in more detail in the future. So this is an async method. So let's see how it works. You don't see any tasks being created. You see that we disable the view, we create the client, we create the object, we do everything as before. The only difference is when we make the post call, remember the post call is already happening in a separate thread. Well, it's asynchronous. So when we make the post call, there's another keyword called await. So await and async go together. Typically, if you write an async method, it'll contain an await keyword. And this is what it means. When you say await client.postAsync, it means what happens is, what postAsync returns is what? What does postAsync return? It returns a task. So you sit here until you get the task back. Okay? And then, when you get the task back, creates for you a task. I'm doing a bad job of explaining this. Okay, let me. I'll tell you the net effect. The net, yeah.
So based on what you've said so far, is this technically just syntactic sugar and not new functionality?
I think it'd be a stretch to call it syntactic sugar, but it's sort of a cleaner way to do what we were doing before manually. So you might be able to argue that. Okay? So the bottom line is what happens with the await is that it takes that task, it doesn't wait for the task to be completed and then continue the way it would have put .result at the end. Instead, it generates code so that when this task completes, basically automatically creates a method such that when that task does complete, this code will be executed. So it packages up the rest of the method so that it can be run in the future and immediately returns. So when you call this thing, it won't wait for post async to return. Instead, it will return a task that does the rest of the method sometime in the future. And then, in the future, when this post async actually does terminate, that task that just got created will actually run. So it packages up the rest of the method into a task, runs it in the future when this method finishes, when this post async task finishes. And, but in the meantime, this method returns and the GUI event thread continues. Yeah?
So this is everything else before the next, like, timeout of this curly brace period. Like,
Well, just everything else. Everything this thing would have done upon a return is packaged up so that this, when the thing does return, that'll be done. Okay? And the neat thing about it is, so it returns immediately. It creates this task and returns immediately. That task will actually be run when post async task finishes. Furthermore, if the original task, if that new task was created in the GUI event thread, it guarantees that the new task that is going to run in the GUI event thread as well. So we don't have to have any cross-thread calls. So we don't have to create tasks or cause them to run or wait for them. All we have to do is put the strategic await in and magic happens. A task is created to finish the work of the method. That task is returned immediately. At some time in the future, that task will be run. And it will be run on the GUI event thread, in this case. So we just write that. Basically, all we had to change about our original method, instead of explicitly creating tasks and all the other crap we had to do with the invoke method, is we took the original method, we made it async up there, we declared it async, and we dropped the await right there. That's all we had to change. That's the only difference between controller 1 and controller 3. And we took off, in controller 1, right here we had a dot result that blocked. We took that off. We put the await, and all the other stuff's done for us automatically. So that await async pattern is really powerful, although I admit poorly explained. So all I've done today is motivate the idea behind the await async pattern. Next time we'll try to look at more detail. I just want to get some idea of what you're buying when you use it.